this demo to explore a little bit about what we learned about resistances and power as demonstrated by some light bulbs here. So in all of these setups, I have 3 different light boards wired in different ways. And they're all using the same wattage light bulb. I think it's a 100-watt light bulb for each one. Okay, so let's do the first one. So in each case, we're powering this by what comes out of the power socket, the electrical outlet there. So we've got 120 watts coming into our circuit board. So here we've got 2 light bulbs in series, and in parallel with those 2, we've got the same 2 light bulbs in series on the left-hand side. So series here, and they're connected in parallel. So I want you to sit and think about if the power of all these light bulbs is the same, that means the resistance of all these light bulbs is the same. What do you think the power used by each of these light bulbs will be? Will they all be lit equally or not? Think about that for a second, pause, and then we'll come back and see. So let's see. For our 2 in series over here, and they're in parallel with 2 in series over here, they will light up exactly the same. Okay? Remember, if we wanted to figure out the resistance here, these 2 are in series, so they would add together to create the resistance on the right half of the circuit. We'd have the same resistance on the left half, and if we wanted to calculate the equivalent resistance of that circuit, we would have to add 1 over the total resistance here, plus 1 over the total resistance here would equal 1 over Req. We'd solve for Req and get the equivalent resistance for our circuit. Okay. That would tell us then, with 120 volts, that would tell us the current going through, and we can then understand everything about the circuit, how much current and how much voltage is going through each of those light bulbs. Now, let's also think a little bit about what happens when we blow a light bulb. If I were to turn out this light bulb on the upper left here and just unscrew it, you'll notice that the one it's connected to in series will also go out too. Because once I disconnect this light bulb, I'm severing the connection. The electrons can't flow on this half of the circuit. So the electrons will only flow on this half of the circuit. Now, if you'll notice, let me screw this in again, you'll notice that when I unscrew it, the brightness of these bulbs did not change, right? So let's look. As I unscrew it, its partner goes out, but the brightness here stays the same. Why is that? Well, because the voltage between here and here is still 120 volts. Just by severing the connection on this half of the circuit, I did nothing to the full circuit down here. These 2 are still connected in series to 120 volts, so their brightness didn't change. Okay? All right. Let's take a look at the next one. So in this board, I've got, again, 3 light bulbs with the same power rating, 100 watts, and I've got 2 of these here wired in series, and then in parallel with those 2, I've got a single light bulb down here. And again, they're all the same wattage, all the same resistance. Okay? So think about this for a second. Which of these light bulbs will glow the brightest? We can probably easily predict that the 2 if they're both the same resistance, the 2 up here in series will be equally as bright, but will the one down here, parallel to it, be brighter or dimmer? Take a minute, pause the video, think about that for a second. Remember, being wired in parallel here means they're both being wired to 120 volts. So 120 volts between these 2 bulbs and 120 volts between this one. So which one glows the brightest? All right, so now that you've made your guess, let's see which one is brightest. The bottom one, right? The reason is because the bottom one gets all 120 volts by itself. the top two bulbs have to split the 120 volts between each of them. So there's a 60 volt drop on the top one, a 60 volt drop on the one here. Together it's 120, so the bottom one glows the brightest. Now what happens, for example, if I turn the bulb out here off? Will the brightness of these bulbs change? What do you think about that? Let's see. No, the brightness didn't change, and for the same reason they didn't change over there, because both of these bulbs are, the connection over these two bulbs is 120 volts, whether or not this bulb is on or not, because that's what a wired parallel means. Okay? Now if I turn off this one, of course I'm severing the connection here, which means no current can flow to the second bulb, so the second bulb has to go out. Okay. All right. Let's go and take a look now at our third setup. I'm going to hold it like this for our third setup. It's easier to understand this way. So I've got one bulb here, and then two bulbs. These two are both in parallel. Okay? So these two are in series with the first bulb. Again, they're all the same power rating, all the same resistance. So think about this for a second. Once I turn this on, this one is, the current's going to go into this one and then split to go into these two. So which of these bulbs is going to be the brightest? Take a second. Again, they're wired to 120 volts. Think about that and make your prediction. All right, so now let's see which bulbs are brightest. The left one winds up being the brightest. Why? Because in parallel, the resistance is much higher than here. So much less a current will be flowing through there. So that means this one becomes the brightest, because power is V times I. All right, so let's think about this a second. Now, let me cover this up so that you can see that these bulbs are indeed lit. It's just they are so much less dimmer, so much less bright than this one here. When you can see this one, you almost can't tell that those are lit at all. Okay, but they are. So what would happen if I turn this one out? Well, that severs the connection here on the series part, so they all go out. Okay. Now let's think about this. In our lecture, we'll actually calculate what's the brightness ratio between these bulbs, and this bulb and this one. So you'll get to actually do the math in the lecture. But here's an interesting thing. What happens if I unscrew this bottom bulb? Will the brightnesses of any of these change? What do you think about that? These are the two bulbs in parallel here that are in series with the first one. If I unscrew this one, what happens? Think about that. Pause the video and come back and we'll see. All right, let's see what happens when we unscrew the bottom bulb here. Now the bulbs are equally lit. The first one got dimmer. The second one got brighter. Why is that? Well, when I sever the connection down here in the parallel part, now I've got two bulbs in series. If I've got two bulbs in series and they both have the same resistance, there'll be equal amounts of power on each of the two bulbs. So they have to be equally lit if they're equal in resistance and power. So this one dimmed, that one got brighter. And if we put them both, remember, the two in parallel, where the resistance is higher, get very small amount of power. The one in series gets the lion's share of the power. Okay.